Good day, everyone. At this point, we will discuss water resources and water pollutants. What are the different water resources and its pollutants? We will start the discussion with freshwater management system, followed by ground and surface water, and lastly, water footprint. This discussion is expected to enlighten us about the different and all kinds of water in the world and how much they comprise of, as well as how bodies of water are being managed. This discussion will also contain brief overview or the ways and system used to manage water. So, let's start. To start with, we will discuss first what is fresh water. Fresh water, either spelled as one or two words, is any naturally occurring liquid or frozen water containing low concentrations of dissolved salts and other totally dissolved solids. To be more precise, fresh water is water containing less than 1,000 milligrams per liter of dissolved solids, most often salt. All fresh water ultimately comes from precipitation of atmospheric water vapor reaching inland lakes, rivers, and groundwater bodies directly, or after melting of snow or ice. Only 2.53% of the global water is fresh water. 1.76% of it is stored in ice caps, glaciers, and permafrost, while all fresh groundwater makes up 0.76% of the global water. It leaves 0.01% only for the surface fresh water, of which 70% or 0.007% of the global water is stored in the freshwater lakes. Fresh water is a renewable and variable but finite natural resource. Fresh water can only be replenished through the process of the water cycle, in which water from seas, lakes, forests, land, rivers, and reservoirs evaporates, forms clouds, and returns inland as precipitation. Locally, however, if more fresh water is consumed through human activities than is naturally restored, this may result in reduced fresh water availability from surface and underground sources and can cause serious damage to surrounding and associated environments. Water pollution and subsequent eutrophication also reduces the availability of fresh water. And this is why we have to manage water and regulate its consumption. And this is where water management comes in. Water management is the control and the movement of water resources to minimize damage to life and property and to maximize efficient beneficial use. Also related to water resource management, it is the activity of planning, developing, distributing, and managing the optimum use of water resources. Ideally, planning has regard to all the competing demands for water and seeks to allocate water on an equitable basis to satisfy all uses and demands. And there are many human ways to maximize efficient use of water. At this point, we'll be discussing three of these systems and technologies, with cloud seeding first, followed by desalination, and the dams and reservoir. Let's start with cloud seeding. Cloud seeding is a type of water modification that aims to change the amount or type of precipitation that falls from clouds by dispersing substances into the air that serves as cloud condensation or ice nuclei, which alter the microphysical processes within the cloud. Cloud seeding can be done from ground-based generators or aircraft. A solution containing a small amount of silver iodide is burned from ground-based generators or released from aircraft. Upon reaching the cloud, the silver iodide acts as a condensation nuclei to aid in the formation of snowflakes or rain. Most efforts at cloud seeding try to increase the levels of precipitation that fall, providing more rain or snow resources to fight drought or other low moisture conditions. Cloud seeding attempts to create more precipitation because of the need to have more condensation fall to the ground. This work can make a positive impact on the regions of our world that see consistent drought problems. This technique helps agricultural workers produce more crops of better quality. It allows groundwater ecosystems to recharge. If cloud seeding is implemented, there will be increased harvesting and more food available from a wide variety of crops for the ever-growing human population. The process also has the potential to improve biomes, allows for more fertility, and create more farming land and land that could be used to build better homes. Such effects can then indirectly create jobs and contribute to financial security for people living in poverty-stricken countries. Next is desalination. Desalination is a process of removing salts or other minerals and contaminants from seawater, brackish water, and wastewater effluent, and it and it is an increasingly common solution to obtain fresh water for human consumption and for domestic or industrial utilization. As populations increase and sources of high-quality fresh drinking water decrease, many communities have considered using the desalination process to provide fresh water when other sources and treatment procedures are uneconomical or not environmentally responsible. Humans cannot drink saline water, but saline water can be made into fresh water, for which there are many uses. Desalination methods can utilize either thermal process or membrane process. The process consists of heating water to the point at which it evaporates and then condenses to obtain fresh water. Next is dams and reservoirs. Dams are structures that are built on a river in order to retain water for one or more specific purposes. Reservoirs are formed behind a dam. A reservoir is a body of water that has been formed or modified by human activity for specific purposes in order to provide a reliable and controllable water resource. Dams and reservoirs can serve a variety of purposes. The purpose of a reservoir dam can be singular or multiple and can also change over time. Water can be stored for municipal use or for irrigation purposes. Dams can be used to generate hydroelectricity. According to the British Dam Society, over 80% of the world's reservoir storage is used for hydropower. Reservoirs may allow for recreational activities such as boating and fishing. Some dams are designed specifically for flood protection. These specific dams are usually designed to reduce flood peaks by 30 to 50% and allow for downstream areas to be evacuated. Reservoirs can be built to contain mine tailings. Next is groundwater and surface water. What are the differences between those water resources? Groundwater is the part of precipitation that seeps down through the soil until it reaches rock material that is saturated with water. Water in the ground is stored in the spaces between rock particles. Groundwater slowly moves underground, generally at a downward angle, and may eventually seep into streams, lakes, and oceans. But surface water is any body of water found on the Earth's surface, including both the salt water in the ocean and the fresh water in rivers, streams, and lakes. Surface water is any body of water above ground, including streams, rivers, lakes, wetlands, reservoirs, and creeks. The ocean, despite being salt water, is also considered surface water. Surface water participates in the hydrologic cycle or water cycle, which involves the movement of water to and from the Earth's surface. Surface water and groundwater are reservoirs that can feed into each other. Where surface water can seep underground to become groundwater, groundwater can resurface on land to replenish surface water. Springs are formed in these locations. Surface water and groundwater are both important sources of core community water supply needs. Groundwater is a common source for single homes and small towns, and rivers and lakes are the usual sources for large cities. Although approximately 98% of liquid fresh water exists as groundwater, much of it occurs very deep. This makes pumping very expensive, preventing the full development and use of all groundwater resources. Next is water footprint. A water footprint shows the extent of water use in relation to consumption by people. The water footprint of an individual, community, or business is defined as the total volume of fresh water used to produce the goods and services consumed by the individual or community or produced by the business. Water use is measured in water volume consumed and or polluted per unit of time. A water footprint can be calculated for any well-defined group of consumers, for example, an individual, family, village, city, province, state, or nation, or producers, such as public organization, public enterprise, or economic sector, for a single process, for any product or service. In 2002, the water footprint concept was introduced in order to have a consumption-based indicator of water use that could provide useful information in addition to the traditional production sector-based indicators of water use. It is analogous to the ecological footprint concept introduced in the 1990s. The water footprint is a geographically explicit indicator, not only showing volumes of water use and pollution, but also the locations. Thus, it gives a grasp on how economic choices and processes influence the availability of adequate water resources and other ecological realities across the globe and vice versa. So there are many different aspects to water footprint and therefore different definitions and measures to describe them. A blue water footprint refers to the volume of water that has been sourced from surface or groundwater resources, has either evaporated or been incorporated into a product or taken from one body of water and returned to another or returned at a different time. Irrigated agriculture, industry, and domestic water use can each have a blue water footprint, while a green water footprint refers to the amount of water from precipitation that, after having been stored in the root zone of the soil, is either lost in the evapotranspiration or incorporated by plants. It is particularly relevant for agricultural, horticultural, and forestry products. The water footprint of a nation is the amount of water used to produce the goods and services consumed by inhabitants of that nation. Analysis of the water footprint of nations illustrates the government dimension of water consumption and pollution by showing that several countries rely heavily on foreign water resources and that many countries significantly and in various ways impact how and how much water is being consumed and polluted elsewhere on Earth. Having knowledge on how to restore, utilize, and maximize water is important. Water is important to live, but they are always been in danger of scarcity. Water is free, but they might become expensive. Water should be treated with utmost care and importance, and it is the duty of everyone. The duty of an individual, the government, a nation, and of the world. This is Arjie Ramirez, and that will be all about freshwater and water management system, ground and surface water, and water footprint. Thank you.